I promise. Today's one of the easiest days that I'm making it. All right. So the very first thing we want to do, though, is decide what a polynomial model is. This is a very real-world application type example. Any business uses what we're doing today. Basically, what happens is if a business or a company or something gets a lot of data, they can write an equation that fits the data, and they use that equation to make predictions. So, for example, if Kellogg's wants to know, month by month, what kind of cereal people are buying, you would think. They'll collect the data for their cereal purchases or sales, or if they want to do like a year by year or something. They'll collect the data, and they'll use that data to come up with an equation. And then they might say, well, in 2017, what's my projection? In 2018, what's my projection? Businesses that want to get started, if they're just kind of in their infancy, will collect their little data, and when they pitch their sales to the bigwigs, they say, we project in 10 years, we're going to be making this much money, whatever. So it's used all the time. Today's study's not quite as exciting, but that's okay. So modeling means that you're creating an equation that fits data. Another name for modeling is regression. When you're looking at the calculator, this word is the one that we're looking for inside whatever buttons. Now you've done this before, probably secondary 1, maybe math 8, I'm not sure where this is taught. But you've done it before. Raise your hand, or does this look familiar? Y equals mx plus b. We know that, right? What does the m stand for? It's so hard because I get into this okay, we're going, and then I have to stop. What does the b stand for? It's the y-intercept, right? Now, we're going to go back to what you did when you were in the 8th or 9th grade. How would I write an equation of the line that passes through these 2 points into this equation? Well, the first thing you need to know is the what? Slope. The slope formula is I need to figure out how the y's change over how the x's change, right? To find the y change, I subtract them. 8 minus 2 over what? 8 minus 2 over 3 minus a negative 3, which would give us 6 over 6, which is 1. My slope is 1. My slope is 1. Is that all right? So far, so good? By the way, this is the only time we'll do anything by hand today. Everything else is on the calculator. You really don't need to just watch them. Okay, the next thing, how would I find the y-intercept? Well, if I use one of these points, I have an x, I have a y, I have an m, could I plug each of those into this and figure out what b is? Yeah, let's do it. So y is 8 equals slope 1 times x, 3 plus b, whatever that is. That's what we're figuring out, right? How do I solve for b? B equals 5. Now what would I do with the 5 and what would I do with the 1 to write my equation? Go back over here. The general format, y equals slope 1 x plus b 5. We don't really like the 1 there. Kind of makes it stuttery. This would be the equation of the line that passes through those 2 points. Okay, and I just wanted you to watch something for a minute. If I have 2 points, through any 2 points there exists exactly one line, right? Through 2 points I can create a line. And given 2 points, I can write a linear equation. If I have 3 points, can I draw a line? Not always, but what do you think I could draw? Yes, or technically no, it would be 3 lines, but yeah. Through 3 points, see if I can do this again. I can draw a parabola. If I'm given 3 points, I can make it quadratic. If I'm given 4 points, I can make a, any ideas? Cubic, or, yeah. If I'm given 4 points, I can write a cubic regression. If you're running 4 points, I can make a cubic happen. So what's the pattern here between those? What's the pattern? It's one less, right? Okay, we need to know that. And we don't need to know that. And what am I doing? Where did I go? Hold on. What am I doing? I don't know. What am I doing? Where did I go? Hold on. Oh. That's an important one. Yeah, here I am. Sorry. Oh my gosh. Nobody watches these anymore. All right. Oh, struggle to I tell you, today is not my day. Okay, so what kind of regression do we choose? If I'm given 2 points, what can I draw for 2 points? A line. So I'm going to choose a... I'm choosing a linear regression if I'm given 2 points. If I'm giving 3 points, I'm going to choose a what kind of regression? Quadratic. Woo. I'm given 4 points. I'm going to draw a cubic, etc. If I'm given 5 points, one less, quartic. If I'm given 6 points, one less, quintic, and so on. So you're going to go through the process of doing that. The very first thing I want to, well, first of all, if you don't remember what to do, and again, these are specified towards the people that, I mean, the bulk of the class has the same type of calculator. If you have an 83, it should be exactly the same. If you have an 82, it should be similar. You guys will be using your stat menu. 84, these are the instructions for an 84. If there's a statistics menu, look there first. Okay, here's what we're going to do. If you don't remember, look at the instructions right here. Ignoring instruction number 1. Let's cross that off. We don't care about it. Okay, the first number 1. Go back up to these points right here. I want to show you how we can do this on the calculator. First thing, let's turn it on. Really quick, I want you to make sure your Y1 is empty. If you have anything in Y1, sometimes it whizzes out. Okay, so right underneath, like next to my variable button is the statistics button. Go there. So my Casio's find your statistics menu. The Casio will bring it right up to the list. The TI doesn't. The TI button gives you a bunch of options. We're going to edit our statistics. L1, I could rename this, although I'm not going to. L1, if I were to rename this, I would call it X. I'm going to put all of my X values in list 1, and I'm going to put all of my Y values in list 2. Now I've got a list of 3, I just need to delete them. I've tried clearing before. Okay, how did I get there? Go to Stat, and then Edit. Delete. If you go up and like clear L1, then it completely deletes the column, and then everything gets screwed up. So don't do that. Okay, I'm using these points that I used in my first example. So my X values are, this one is -3, right? The next one is +3. I'm just looking at the X values first. Then, under list 2, I'm going to be looking at my Y values. So the -3 matches up with 2, and the +3 matches up with 8, right? So if I were to look at them in order, -3, 2, that's 1 point, 3, 8 is the other point, right? Then, I'm going to go back to the Stat button, and now I want to calculate something. I want to calculate a linear regression model. So under Calculate, if you scroll over, there's a bunch of choices. We'll be using option 1 a little bit later on in the year when we do statistics. But if you go down to option 4, 5, 6, 7, do you see all the different regressions? We've got linear regression, quad, cubic regression, quartic regression. This time we want what? Linear, because there's only two. I click linear. Now yours could look like this, or it could look just kind of like the very, very top part and that's it. Any questions about how it looks like? Okay, it's possible that this is blank. If yours is blank, then it defaults using list 1 and list 2, so you don't have to change anything. To get here, go stat, calc, and then option 4, the fourth one down, linear regression. So it's telling me right now, I'm going to pull my information from list 1 and list 2. So just enter through all of this. We don't have to worry about whatever this frequency list thing. We'll talk about the store regression in a minute. So you want to go calculate. Now, yours again might look a little bit different than mine. You may not have the r squared and the 1. And I'll talk about r squared and 1 in just a minute. But does it have a equals 1, b equals 5? Isn't that what we got right here? Don't you wish you knew how to do this when you had to do all of those by hand in the 8th or 9th grade? Yeah. Okay, so let's practice it. Any other questions? So let's do it again. Instead of this time, let's look at these examples. Yep. Okay, let's do it again, and I'll walk around and make sure everybody's on the same page. Really quick, who still needs to get a calculator? You guys. Don't worry about the R. Okay, let's do it again. So how do I get to my list? Stat, edit. In my L1, what will I put? I'm just going to start calling on people. Aaron, what do I put in L1? Okay, what are they on part A? As long as, if I put -3 first, I've got to be putting 13 by it, so put them together. Yeah. Okay, if I put 4 first next to the 4, my y value is -1. Next to the -3, my y value is 13. Okay, so list or stat, edit, list 1, list 2. How do I start calculating things now? How do I get to the calculate button? Stat, calculate. Option 4, it's linear, so I only have 2 points. We ignore everything. This may not even pop up for all of you. Go to calculate. A equals -2, b equals 7. The r's we don't care about right now. If your b and your a is wrong or different than mine, go back to your list. Did you put them in the right order? Did you put 4? Oh, did I screw up? No. The 4 goes with -1. The -3 goes to 13. So if any of these digits are wrong, your A's and B's will be different than mine. So you've already got B then. Okay, what did we get again? So how do I use this to write my equation? Y equals what? A, -2x. And then I think it was 7 plus 7. Done. Fantastic. That's it. So try part B on your own. I'm going to walk through it and help. Literally, so you have your list, right? And then if you push this button, you exit. I literally didn't want to do it. Try that out. Calculate button. Go back to now. From here, representing similar graph calc test. That's 6. Okay, so we've got the graph calculated test. They were all assessed for test 2. And then we'll break it. And then you had your options x squared, x cubic. So yours doesn't say cubic, quadratic, whatever. It just deals it with the x. Does that make sense? So you use x because you know the denominator regression. And then you have the x plus b, right? How you want it? Again. I said I got done. All right, what you get for part B? Any questions getting y equals negative x plus 2? You feel good about that? Any questions? Because now's the time to ask. If there are. Yes. Just on B, yeah. What about part C? This time on part C, if I edit my list, I'm going to have 3 in L1. So tell me what goes in L1. 1, 0. Okay, what about in list 2? 15, 11, 6. Is that all right? So now what? Stat, calc. This time I'm getting 3 points. So now I'm going to be doing a quadratic regression. Option 5. So A is 2, B is 3, C is 6. So how? R squared is telling you how well the equation of the graph fits your data. So if my R squared is 1, that means these 3 points are on this equation. Now if my R squared was 0.9 or 0.8, that means they're not quite on the equation, but they're really close. Now through, yeah, that's what it means. So what do we write here? Y equals 2x squared plus 3x plus 6. And if I were doing this one, I would choose a what kind of regression? Cubic. I want to show you something else. Just watch. I'm going to go back to stat, calculate, quadratic. Now, do you see right here where it says store regression equation? I can store this, and I'll show you how. I mean, I'm going through it right now, but I'll go slower in a second. I can store my regression equation into y1, which is in here, when I calculate, the same thing as normal comes up. I get my a, my b, and my c. But if I look in the y equals, it's now in there. A is 2, which that's pretty much 2, right? X squared plus, that's pretty much 3, right? Plus c. And I can graph it. Now, why do we care about the graph? We're going to be using the graph to predict what's happening as time moves on. So, I'll show you how to do that. Let's move on to the next page. So, number 3, let x be the number of years after 1985. This right here is kind of critical. It's going to tell me what x values to plug in. So, if I want my x to start in 1985, which was a really long time ago, what would this year be? In 1985, x would be 0, right? Because that's the starting year. 1990 would be what? 5 years after the starting point. 95 would be 10 years after, and then 15. Is that okay? When I open my statistics list, I'm not going to put in 85, 90, 95, 2000. I'm going to put in 0, 5, 10, 15, so on. So my x values will be 0, 5, 10, and 15. Now these ones are going to give us some pretty horrendous decimals. Let's just say I want 2 decimal places after any given 0. So if it was 0.0012, I want 0.0012. 2 decimal places after a 0. Okay, what's going to line up with the 0 here? 49.3, 70.2, 71.8, 82.6. Is that okay? And let's talk really quick. What are we even figuring out? We're coming up with an equation that has to do with the production of gold. And that's what this data is. In troy ounces. I don't know what troy ounces are, but whatever this is, it's in troy ounces. Okay, so how do I come up with the equation? That. Calculate. It's going to be a cubic this time because there's 4 data points. I'm going to want to store my regression. Now, some of yours doesn't have the little button that says store regression, right? Don't worry about it. You'll do the exact same thing I'm doing right now. It'll just pop up right next to your cubic regression word. Okay, to get where I'm storing this, I go to vars, variables, vars. I go over to y vars, because I'm saving it into the y1 function. And there's a list of all of the possible functions I could save it to. I want to save it to y1. Anyone need help getting that? Yeah, do it again. Okay, ready? Bars. Then what? Okay, we're in the list, right? And now you've gone stat, calc. What are we calculating? The cubic. Now, not all of yours look this way. Is yours one that just has a line up on top? What are the cubics? And now yours just has a one, right? That's okay. Do the same thing. So how? Okay, so I have this point right here, and now I'll walk through. Okay. Okay, some of yours just has cubic regression. It doesn't have L1, L2, anything. It just has cubic regression. If I need to, I can get my, yeah, we'll do it. Okay, now I got to get the Y1 right here. Or in your case, it would be like the Y1 right here, right? Go to vars, then what? Yep, then what? And so yours should say cubic regression y1, right? Does it? questions? Are you okay? You good? Good. And then did you calculate? Sorry, I should have done this also rather than okay, so what do we get here with functions? So y equals, you'll have to help me out because mine drops. Y equals 0.038 what? X cubed plus minus 0.95 x squared and what? 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 Okay, so there's my regression model. Now, how do I estimate what happens to the world gold production for those years? Well, first of all, what are the x values for those years? In 2010, how many years after 85 is that? 25 years after 85? Like if 0 is in 85, 2010 would be 25 years out. And then 2020 would be 35. And then 40. So I want to know what happens when x is equal to these three things. So go back to your calculator. Really quick, look at your window. Let's make sure our x value goes all the way over so it hits the 40. Is that okay? All of these numbers need to be in the domain of your window, otherwise the calculator kind of wigs out. When I graph it, I'm only going to really see a piece of the graph, and that's okay. So that's kind of what's happening with the gold consumption, or not consumption, gold production. What's your window? All right, so if I want to know what's happening in the year 2010, yes. In the x. The x's, yeah. Oh, any other? I think that what happened is by pushing enter, you made it calculate it, and had it calculated it beforehand. Okay, so here's how I'm going to, I know this takes a long time to make sure everybody's calculator is on the same page, and I'm sorry that it's boring a little bit. Okay, so go to our graph. If I want to find out what's happening in year 25, I'm going to trace, and I want to know what's happening in year 25. It's so high off my graph I don't see it, but I don't really care if I see it because my number's right here, right? So in 2010, there will be 245.8 troy ounces, whatever that means in gold. I should look up better studies because these are dumb. If I want to know what happens in year 35, what do I do? What do I do? Trace, then what? 35? 787.8 ounces. I don't know what that is. Okay. And then how do I figure out what's happening in year 40? Enter. $1,271 point something. Okay, let's do one more. Question. Let's do it. Do you feel okay? I'm going to get you started on this next one, and I'll come around and ask for questions. This is the number of years of after 1970, and it's the life expectancy for females. So in 1970, the average woman lived to be 74.7 years old. I don't know. In 1980, if this is true, if we can make a prediction, we can figure that out. Yeah, so if this is my year 0, then my x values would be what? 0, because it's 1970, 10, 20, 30. So I want you to come up with the prediction, or the regression. And I need to point something out really quick. And then I want you to try estimating the expectancy. Now these numbers are very important to me. 1960 is the year my mother was born. 1981 is the year I was born. And the year you were. See, 3 very important people in my life. My mother, myself, and you. Okay? Okay. Okay, cool. See if you can plot the whole thing. I'm going to do it off to the side and then I'm coming around. There's 2 kind of running jokes in my family, and I don't know how appropriate they are, so I'll share them anyway. The first one, because we were talking about Family Feud one time, and my aunt, my mom's sister. In my mom's family, it's my aunt and my uncle, and then cousins. Like, those are the only people that are left. My mom's gone, my grandparents are gone, it's just my aunt and my uncle, and then us cousins. Anyway, so we were talking about Family Feud, and my aunt said that there weren't enough people in her family to actually be able to play Family Feud, and my dad told her it's because we all died, which is sort of true, and that's sad. And then the other one is there's not enough people in my mom's family to play Family Feud because there's not enough smart people in her family to play Family Feud. Kidding. My math, I used to ask my mom for help with fractions because I knew she couldn't do them, and I knew it just made her mad when I asked her about them. I had no problem with fractions, but I knew she did, so I asked her for help. Okay, so that's your equation. You can write that down. Now wait, really quick. That calculate. Sorry, I got distracted with like family drama. 6. Store it. You got the bars, y bars, function, y1. Now, what is this number right here? E negative 4. Be really careful with that. I'm not going to put 1.3x to the 4th. What am I going to put? This right here means 1.33 times 10 to the negative 4. So this decimal point goes over 4 times. So I've got how many zeros? 3 zeros. So this is y equals. Now this is an important term in my equation. If I just say that's close enough to 0, I can get rid of it. I've done something wrong. So 0.00013x cubed. Whew. That one should be there. Keep going. What's B? Minus 0.01 x squared. Is that okay? Plus 0.36 x cubed, nope, x plus 74.7. Did you? Good. How's it coming for you? Got it. Good. Lee, you got it? Good. Yeah. Did you get it? Are you okay with the regression? Not quite? Working on it. Now, Lainey, did you figure out how to, I think yours automatically stores it in the y equal, is that right? Yeah, that's nice. So once you click on your regression rate, it will automatically store it for you. And then you can like calculate your response. Wagner? No, I'm so done. Okay, so if I'm trying to figure out what's happening in 1960, what would my x value be? Because my 0 is at 70, right? This would be negative 10. What about 81? 11. And then the year you were born? 30, you were born in 2000. I graduated in 2000 from high school. Okay, let's plug them in. Now when I graph this, it kind of looks like a line, right? And I'm not super surprised because this is a very small number. I could almost get rid of it. This is a very small number. I could almost get rid of it. And if I did, that would be linear. So I'm not surprised that it kind of looks linear. This is a way stretched out function, right? The point 0, 0, 0, 0. Hey!
What are we learning?
Regression models. Secondary 3.
We're going to do that this time.
You
have this recorded right now?
Right now. Play it. Is that what you're recording tomorrow?
I was, but now I got to switch them off.
Oh, okay. Here we go.
You guys understand this?
They're like, will you shut up already? They're ready for me to move on. Yeah. Done. They're easy if they have a graphing calculator. Those that don't.
It sucks it up. You got to do some good old system equations.
Which we aren't even talking about.
So that's what you have to do.
It's a very complicated process. We did a linear one, and then I said that's it. It's just a guess. Good.
Enjoy your life.
This is a perk of living in the hallway that I did not experience last year. He stops by about once a day in random classes to say hello. Okay, so how long is somebody in 1960 going to live? Estimated, obviously, it's not always accurate. Trace, that's not a trace button. Trace, negative 10. It's predicted that the average woman that was born in 1960 lived to be 69.970 years old almost. Somebody born in my year, 77.6-ish. So should we figure out what that is, that thing? Okay, next one. Last one. Somebody, a woman born in the year 2000, almost 80. But you know what? This is old data, right? If we use, I guess it's got to be kind of old because somebody born in 2000 probably, yeah, anyway. Anyway, there it is. Thanks for watching. Peace out.